Nice students, now comes question number 8. So here we are going to see another problem, and it says here that you are having 3 by 3 matrix, matrix A. As you see, the entries are all labeled here, and here you are asked to find a matrix B such that 4A minus 3B is a scalar matrix having this property. The determinant of 12B minus 16A is negative 512. Okay, so you are asked to determine another matrix B provided that certain conditions are given for you. So let me show you how this can be done. So the procedure goes like this. It has been said that here the matrix for A minus 3B is a scalar. You know, student, that a scalar matrix is a square matrix having diagonal entries identical, right? So let's assume that for A minus 3B is, you see, denoted by this one. I just have used this 3 by 3 scalar matrix. The reason why I'm using 3 by 3 here is because my matrix A is a 3 by 3 matrix. So look, 4 times A is nothing, but it is again a scalar matrix. I mean, it is a matrix of size 3 by 3. So clearly, since it is operated with matrix B, even if it's multiple with 3, since it is operated with matrix A, matrix B is operated with matrix A, it is expected that matrix B is also a 3 by 3 matrix. That's the reason why I'm taking a 3 by 3 matrix like this. So we have K to be a certain arbitrary real number. So I am now using a scalar matrix of size 3 by 3, which actually is, you see, having k diagonal entries. So this is basically what? A scalar matrix of size 3 by 3 according to the given information. Now proceeding to this, what is the determinant of a scalar matrix, student? Remember determinant property. For a scalar matrix, the determinant is nothing but it is the product of the diagonal entries, right? So let's multiple these 3 k's. So when you multiple these 3 k's, look, k times k times k. You do this whenever you have a scalar matrix. Basically, not only scalar matrix, whatever upper or triangular matrix you might have, you can do like that, okay? The determinant is nothing but it is a product of the diagonal entries. Remember those properties of determinants. Then you get k cubed. So look, the determinant of 4A minus 3B is going to be k cubed. Now, let's compare what has been written here with this one. You see, guys, this is 12B minus 16A, whereas this is 4A minus 3B. Now think of a certain scalar number where you can multiply that to this expression in order to obtain this one, 12B minus 16A. So look, 12B minus 16A is basically the same as negative 4 times 4A minus 3B. If you multiply negative 4 by 4A minus 3B, you'll come across with this output, 12B minus 16A. So again, we are going to apply another determinant property in order to evaluate or in order to find this matrix B, okay? So here comes. Since the determinant of 12B minus 16A is the same as the determinant of negative 4 times 4A minus 3B, because if you multiply negative 4 with 4A, you will obtain minus 16A, and negative 4 times minus 3B comes to be positive 12B. So the two are the same, all right? Okay. So from this, what's going to come here is this one, okay? Look, this is negative 4 cubed. Remember, student, that whenever a matrix is multiplied by a certain scalar number, and if you are asked to find or to determine the determinant of that matrix, what you need to do is take the scalar number out as a coefficient and then take the exponent to be the size of the matrix. Since we are having, you see, a matrix of size 3 by 3, a matrix of size 3 by 3, we need to take 3 as exponent here. So minus 4 cubed is going to be used. So directly this minus 4 is taken from this one, students. Had you, for instance, have number 2, this number 2 could have been taken to this side. And had this been a matrix of size 4 by 4 or 2 by 2, this 3 would have been changed to either 4 or 2. If this is 2 by 2, you will take 2. If this is 4 by 4, you could have taken what? Number 4 here. So anyway, for the time being, you're having now minus 4 to the power of 3. Then this determinant goes to this one, 4A minus 3B. So the determinant of 4A minus 3B is going to follow. But we knew that the determinant of 4a minus 3b is k cube, students, k cube. Since minus 4 cube makes minus 64, you are going to have minus 64 k cube. I just brought this k cube directly from this. Now, students, you have been told here at the beginning that the determinant of 12b minus 16a is negative 512. So you simply copy this and paste here, negative 512. Now, students, negative 64 k cube equals negative 512. So from this, one can determine easily what k is going to be. So clearly, k cube is 8, right? K cube is going to be 8. So we obtain k to be negative 2. So from this, what you need to do is you directly substitute k equals minus 2 here, student. Look, you have been told that 4a minus 3b is, look, 4a minus 3b is a scalar matrix having entries kk. You see, as you see, diagonal entries kk. So in place of this k, we are going to put, okay, minus 2 throughout, okay? Here I just have written number 2 wrongly. Please make this to be 0, because look, this is 2, it is wrongly written. Make it 0, please. This is 0 as it was stated here. So actually it is corrected as you see here. So for a minus 3b is going to be, as you see, minus 2 0 0 0 minus 2 0 0 0 minus 2. Look, students, now what's going to come? You are asked to determine what matrix B is going to be, but now you obtained 4a minus 3b to be like this. We knew what a is, right? So you simply copy this matrix and substitute that here. You see, student? So as you see, 4a minus 3b is going to be like this. Look, now take this minus 3b to the right, students. Take this minus 3b to the right and move this matrix to the left. So you are left with 4 times matrix A, which actually this one, look, this is 4, and this is matrix A. I simply copied this and pasted here. 4 times A minus this matrix, student. Look, this matrix is going to come. So we need to operate this one. So the output for this is going to be 3 times of B, not B actually, it is 3 times of B. So let you see what has been done. 4 times 1 is 4, and 4 minus 2 makes 6. Do the same for the rest. 4 times negative 3 is negative 12. Negative 12 minus 0 is negative 12, as you see. 4 times 3 makes 12. 12 minus 0 is again 12. Do the same for the rest. You can do. Let me check the third row entries. 4 times minus 3, negative 12. Negative 12 minus 0 is again negative 12. 4 times 6, 24. 24 minus 0 is 24, as you see. And for the last, 4 times 1 is 4, minus 2 makes 6, because 4 plus 2 makes 6. Do the same for the second row entries. So you see, students, 3b now is obtained. It is a matrix having these entries. The question is not to find 3b, rather to find matrix B. So what you need to do is you have to divide, you see, everything by 3 in order to determine what B is going to be, okay? So dividing what? This matrix by 1 over 3, we can have the following what? Expression. 1 over 3 into 6 minus 12, 12, 0, 6, 0, negative 12, 24, 6. As you see, this can come. So what comes next is, this is basically a scalar multiplication of a matrix. So we need to multiply each entry of this matrix by 1 over 3, students. When we divide each entry by 1 over 3, one can obtain the following one. Look, these can be obtained. 6 divided by, or 6 times 1 over 3 is 2. Negative 12 times 1 over 3 is minus 4, as you see. And 12 times 1 over 3 is 4. So it's a matter of dividing each entry by 3. When you do so, 0, 6 divided by 3 is again 2. 0 divided by 3 is 0. Minus 12 divided by 3 makes minus 4. 24 divided by 3, 8. 6 divided by 3, 2. So dear students, in order to satisfy the above condition, taking matrix A as it is given, and determinant of 12b minus 16a, 512, you see, and 4a minus 3b to be a scalar, so matrix B was required. So this shows you that matrix B is a 3 by 3 matrix with this entries. Entries 2 minus 4, 2 minus 4, 4, 0 to 0, minus 4, 8, 2. I hope you have understood.